Emonitor Plotting, Part 2, Exploring Plot Views. This video is the second of a two-part series that demonstrates some of Emonitor's extensive plotting capabilities. In this particular video, we'll explore a number of Emonitor's multiple plot views and demonstrate some of the options available within each plot. In the first video, we walked through the basics of working with single plots. So if you haven't already seen that one, be sure to check it out. Part 1, Single Plot Basics. So let's go get into some multi-plot views. You'll find access to Emonitor's plot views from the toolbar on the small plot button, fourth from the left. When we open up that, you'll see a fairly long list of available plot views. These are all standard plot views that come with a standard Emonitor installation. However, Emonitor is highly customizable, and plot views are no exception. You can create and save plot views to your liking. Let's explore some of Emonitor's most popular plot views. When we look at the Auto View plot view, this particular one will draw a plot pane for every measurement on the particular cursored location. So in this case, we'll get quite a number of plot panes in one single view. So with Auto View selected, we'll click OK, and we're presented with a bunch of plot panes. Not all of those measurements contained data, which is why some of these plots are blank. All of these plots are linked by timestamp, however. The Link Unlink button is up here on the toolbar. So if I were to, for example, select a particular point on this trend plot, the other plots will update to reflect the closest data with a matching timestamp to the point that I've selected on the trend plot. Let's take a look at some other plot views. I'm going to once again open the plot view list, and let's select Waterfall. Waterfall gives us a history of our spectra measurements. You can see the oldest measurement in this sample is presented at the bottom or the front of the plot. And in the back of the plot, you'll see the latest measurement sample we have for this particular measurement. At the XYZ intersection, here in the upper right, we can double click and hold, and we can reposition the perspective on the waterfall to help us see the individual peaks a little bit better. The cursor is a two-way cursor, meaning that the line that goes on the bottom is moved left and right using the arrow keys, or you can use Shift arrow key to move them in larger increments, moving them along the x-axis or the frequency axis. The vertical line moves back and forth with the up and down arrow keys to each measurement sample and can be positioned on a particular frequency. Some other interesting things about this plot, as with a standard spectrum plot, the inches per second units can be toggled to scroll through different units, and the amplitude scale will rescale to reflect those units. You can also choose Gs, for example, which accentuates higher frequencies and suppresses lower frequencies, often the units you will use for watching bearing defects. But if the default units you're taking data in this particular case are inches per second, and you'd like to see what it would look like in Gs, you can interpolate this on the fly. We'll put it back to inches per second. We're currently using no filter on this particular measurement, and you can also toggle peak signal detection to peak or RMS. And down here, you can track your speed in either CPM, in orders, or in hertz. And then the x-axis scale will change to reflect that. All right, let's move on. If we take a look at the frequency band, it will give us a plot pane for each frequency band in the band set that we have set in the particular machine category for this measurement. Now, Emonitor uses categories to control a variety of things, but you can assign alarm thresholds based on the category and the particular band set that you've chosen. This is a standard 6-band set, and so it gives us the trend of the energy in each one of those 6 bands. This is pretty handy because this is all calculated on the fly, and this means I don't absolutely have to have separate measurements for each band if I don't want to. I can get all that information from a single spectrum and trend it just on demand. Going back to our plot selection, let's look at frequency trend. This is a pretty interesting plot view, very powerful tool here for the vibration analysts in the group. In addition to having our waterfall in the upper right-hand corner, and then the active cursored spectra plot in the upper left-hand corner, on the bottom pane, what we actually have is a dynamically calculated trend of the energy in a dynamically specified frequency band. And so what I mean by that is, if I put a cursor on this particular spectrum, if you look closely, you'll see it's a double line rather than a single line as you might normally expect. Using the control key and the right arrow, I can widen this band. So I'm defining a band with a width of 630 CPM, as indicated here. And then that band, the energy in that band is trended for me automatically in the bottom pane. You can grab that band and move it anywhere in the plot. So for example, if I had some developing haystacking on my spectra plots and I wanted to see how long that energy was present in the trend and whether this was a recently developing phenomena or something that's been going on for a while, you might be able to see it in the waterfall depending on the density of the data that you're tracking in the waterfall. But you could also just simply draw a band with this particular plot view around the peak with any that included the haystacking below it, and then Emonitor would show you the trend of the energy, and you'd be able to see very quickly whether or not that kind of haystacking has been going on for a long time. Let's take a look next at orbit plots. In order to view an orbit plot, we need to have 2 synchronized time waveforms in an X and Y orientation. And we have our 2 time waveforms. Now, for these to display properly, we have to tell the polar plot part of the view in our options by double-clicking in the margin here which time waveform measurement is which. So I'm currently cursored on the X-axis one. So I will select current measurement and it'll pre-fill in those position and direction for me. I will then click on the Y-axis tab and again click current measurement. Now since I'm on the X direction, I'll need to change the direction to reflect the actual that I want, which is Y, and I'll apply that. And now you see we will get an orbit plot. This one is giving us sort of the characteristic figure 8 shape that is representative of a phase change. The direction of rotation is indicated by the arrow, and there's a little gray pad on the top and bottom which are indicating the specified sensor orientation, and those values are provided in the location pane. And you must fill in those sensor orientation values or you will not get the expected result in the orbit plot. Let's continue on with some other options here. The HVA plot gives us horizontal, vertical, and axial spectra if we're taking all those directions. So let me again switch data and go back to my regular PA fan here. Come back and pick my horizontal, vertical, and axial. And we will get 3 plot panes. In this case, I'm not taking an axial spectrum, but I am taking the horizontal and vertical. But this is an easy way to compare spectra in all three directions without overlaying them in the spectrum plot. That's also an option. You can tag those measurements individually and view them all in one plot if you would prefer. Another way to compare two spectrum plots, for example, would be if you wanted to, say, compare the current spectrum to the baseline. You could, as I mentioned, overlay those plots by tagging them and then looking at the spectrum and then choosing to overlay that data. But there's actually a better view for that makes that a little bit more easy to interpret what's going on, and that's called the baseline differential. Notice there's a baseline ratio which simply divides the two spectra from each other. The differential subtracts them, as you'll see. So the baseline measurement is listed here in the legend. You can see it's the one on the right. And in this particular case, my 2 times peak is pretty tall compared to the latest cursored spectrum. So if I were to put cursors on those peaks and then click on this particular peak in the bottom one represents the subtraction of the current spectrum from the baseline. So I actually have a negative amplitude because my peak has gone down. Now, one place where that is not true is on this particular peak right here. So we could click on this peak in the plot and position it with the arrow keys if we need to, and it'll put the cursor on the spot of both the baseline and the current cursored spectrum and show us that in fact there is some new energy here compared to the baseline. So that's a pretty cool plot. Let's press on. The shaft center line allows you to plot a polar plot using 2 position measurements. We can do a standard time waveform plot, standard trend plot. These are actually not multi-plot views. If you want to look at a trend plus spectrum, this is a quick, nice stacked trend and spectrum. It puts the legend down at the bottom and gives you the spectrum in the left-hand side and the trend on the right. And again, as usual, these are linked plots. And with any other spectrum plot, you can toggle through the x-axis units and the y-axis units and the signal detection, however you would prefer to look at the data. A couple of other interesting plots. The units trend is designed for primarily oil data. You can use the units trend for really any kind of data. Let me give you an example. We will go to some oil data, since that's what this particular view is primarily geared toward. And if I pick units trend from the list, you'll see that I get all of the units, or in this case elements, that we are tracking in oil data on the top bar chart. And if I cursor a particular element, you'll get the trend of that particular element in the bottom trend chart. Now, you can put alarms on this just as you can with any other magnitude or numeric measurement. Now, it can be, especially in the case of oil data, that we have so many units that it can get very busy. We may not want to look at all the units at one time. So we can double click in the plot margin, go to the Data tab, and here we can select just the particular measurements that we want. We can double click them, or we can click and add. Both of those methods work to add them to the list. So we can pick just the things that we're interested in and then apply, and we'll get a shortened version of the element list. As I said, these don't have to be oil analysis elements. These could be just individual measurements that we are trending, numeric values. So you could have, for example, if you were trending band values, you could have all of your band values represented by a bar chart, and you could look at the relative trend of each band value as you click through. Let's take a look at one last view. We'll go back to our PA fan data again. Probably one of our most popular vibration analysis views is called, coincidentally, Vibe Analysis. And it'll look very similar to the frequency trend plot. The big difference is that instead of a dynamically defined frequency band trend at the bottom, this is actually our overall. So this is somewhat similar to our trend and spectrum, except instead of just the trend and the spectrum, we're getting the trend, spectrum, and waterfall. If I'm working from the waterfall, I can position the cursor on the waterfall I'm interested in, and it will activate the current spectrum with that as well. Now it might be that I want to click on the first data point that has gone into alarm, because in this particular data point I'm looking at the overall, and the overall tells me something has changed, but it does not tell me what's driving that change. So if I want to see what has changed from this particular measurement to this one, I can take a look and see what's driving that energy. So as I click between these 2 points, you can watch and see that the overall has gone up and the 2 times has gone up, just slightly. So that's just enough amplitude in those 2 peaks to drive a change in the overall to putting me in the warning alarm state. So that's a pretty handy view as well. So I hope you've enjoyed this discussion of our Emonitor's multi-plot views, and we look forward to seeing you in the next video. Thanks very much.